In 1543, just days before his death, Freemason and Jesuit Nicholas Copernicus published his book On the Revolutions of the Celestial Spheres, which revived the old heliocentric cosmology of Pythagoras and began the so-called Copernican revolution away from a flat geocentric model and towards a global heliocentric model. Since his book claimed Earth to be a tilting, wobbling, spinning sphere revolving at breakneck speeds around a stationary sun, it was initially met with due incredulity. Copernicus always countered this by claiming his theories were merely hypotheses and shouldn't be considered truth. In his book he even wrote, quote, "The Pythagorean teaching was founded upon hypothesis, and it is not necessary that the hypothesis should be true, or even probable. The hypothesis of the movement of the earth is only one which is useful to explain phenomena, but it should not be considered as an absolute truth." Contemporaries of Copernicus, such as Danish astronomer Tycho Brahe, famously argued against his heliocentric model, positing that if the Earth revolved in an orbit around the Sun, the change in relative position of the stars after 6 months of orbital motion could not fail to be seen. Brahe wrote that the stars should seem to separate as we approach and come together as we recede. In actual fact, however, after millions of miles of supposed orbit around the Sun, not a single inch of parallax could be detected in the stars. As even Wikipedia notes, quote, "The lack of any observable parallax was considered a fatal flaw in any non-geocentric theory." Copernicus's answer to this obvious problem was simple. He moved the stars so ridiculously far away from the Earth that even after millions of miles of supposed orbit around the Sun, no appreciable parallax could be detected. Copernicus simply needed to claim that the stars were trillions upon trillions of miles away, so then, mathematically speaking, it would indeed be impossible to detect such slight parallax. Again, contemporaries of Copernicus argued against this convenient correction of his, arguing quite rightly that if the stars were trillions of miles away, then there is no way we could see them. Backpedaling once again, Copernicus claimed the reason we could still see stars trillions of miles away was because they were not mere tiny points of translucent light in the night sky, but that stars were in fact gigantic gas balls billions of times larger than our sun. So first, Copernicus had to move the stars trillions of miles from Earth to explain away lack of parallax, and then he had to make the stars billions of times larger to account for why we should see them at all from such fantastical distances. Lastly, he offered very specific distances and mathematical equations to solidify his theory, claiming, for instance, that he had accurately calculated the Sun's distance from Earth to be exactly 3,391,200 miles. At the turn of the 17th century, Tycho Brahe, under the patronage of Emperor Rudolf II, began construction of the largest, most state-of-the-art astronomical observatory ever built. Upon hearing this, German astronomer and Freemason Johannes Kepler was determined to apprentice under Brahe. Even though Kepler championed Copernicus's widely disputed heliocentric globe-Earth theory, Brahe begrudgingly accepted Kepler as his apprentice based on his merit as an astute astronomer and mathematician. Brahe allowed Kepler access to the observatory, but guarded his data and findings from him completely, which frustrated and angered Kepler to the point of eventually culminating in a heated argument between the two of them, resulting in Brahe kicking Kepler out. After much amends and apologizing, a year later, Brahe finally forgave Kepler and accepted him back as apprentice. This time, however, Kepler was not content with his role as mere apprentice and soon proposed and secured a commissioned position on Brahe and Emperor Rudolph's new project, the Rudolphine Astronomical Tables. Less than a month later, Tycho Brahe mysteriously dropped dead, and Johannes Kepler was given access to all of Brahe's coveted data, free rein of the observatory, and became Emperor Rudolph's new official astronomer. Abundant circumstantial evidence and obvious motive have long fed speculation that Kepler actually murdered Brahe. Brahe was only 54 years old and in fine health when suddenly he became deathly ill and passed away. His official cause of death was reported as a bladder infection, but subsequent autopsies of his body revealed toxic quantities of mercury present on his mustache hairs, which has led many researchers to conclude he was poisoned. The 2004 book Heavenly Intrigue suggested that Kepler had indeed murdered Brahe to gain access to his data. Kepler himself never denied this, and he actually wrote, quote, "I confess that when Tycho died, I quickly took advantage of the absence, or lack of circumspection, of the heirs, by taking the observations under my care, or perhaps usurping them." And so for the remainder of his life, Kepler worked at Brahe's observatory for Brahe's employer, using Brahe's data to further his Copernican theories, which Brahe had always criticized. He modified Copernicus's calculations of celestial motions, changing them from perfect circles to irregular ellipses, and even formulated a new updated distance of the Sun from Earth. While Copernicus had claimed positively the Sun to be 3,391,200 miles from Earth, Kepler assured the astronomical community that his new figure of 12,376,800 miles was the true distance. A few years later, in 1608, the first telescope was invented, and by 1609, the next champion of Copernicism, Italian astronomer, Freemason, and probable Jesuit Galileo Galilei, had purchased and built several of them. Galileo improved upon the telescope's design, boosting the zoom capabilities from the original 3 times up to 30 times magnification, and in 1610 made the most important alleged discovery of his career. With his 30 times zoom telescope, Galileo claimed to have seen what he described as, quote, 3 fixed stars, totally invisible by their smallness, all close to Jupiter and lying on a straight line through it. After tracking these invisible stars for a while and noticing they appeared sometimes but not others, Galileo concluded that when he could not find them, they must be hiding behind Jupiter, and therefore they must not be invisible stars at all, but rather invisible moons orbiting Jupiter. His alleged discovery of moons orbiting Jupiter was then touted as proof of the Copernican system, claiming that Earth must be a planet like Jupiter since both have orbiting moons. To this day, NASA claims to have special telescopes which can, on occasion, see these moons of Jupiter, just as Galileo claimed in his day to see, on occasion, with his special telescopes. Nowadays, with modern telescopes and zoom technology, we can see the celestial bodies far closer and with far more clarity than Galileo could have ever hoped for. A 2016 Nikon P900 has 83 times optical zoom and 332 times digital capabilities, which put Galilean telescopes to shame. Yet even with this level of magnification, Galileo's alleged invisible stars orbiting Jupiter are nowhere to be found. Galileo and his fellow Mason predecessors, acting more like true believers of their heliocentric faith than legitimate scientists, were constantly guilty of inventing elaborate theories to support their foregone conclusion. This was never more evident than when Galileo presented his theory on the cause of tides in 1616. Cardinal Bellarmine had written Galileo the year before, stating that, quote, "The Copernican system could not be defended without a true physical demonstration that the sun does not circle the earth, but the earth circles the sun." Taking this to heart, Galileo hoped to show that the Earth's tides were caused by the sloshing back and forth of water as a point on Earth's surface sped up and slowed down due to Earth's alleged rotation on axis and revolution around the sun. He argued that these hypothetical motions of his globular Earth were the cause of tides, and therefore the tides themselves were proof of Earth's motion. Unfortunately for Galileo, his ideas were not accepted and easily proven wrong by his contemporaries, who rightly pointed out that if his theory were correct, there would only be one high tide per day. Not only this, but if tides were caused by Earth's alleged motion, all lakes, ponds, and other inland bodies of water should be similarly affected, yet they are not.